In this problem, we have a sequence, s sub n is equal to negative 1 to the n over n factorial, and this sequence is valid for n greater than or equal to 0. And we have to show that it satisfies this recurrence relation. So to do that, all we have to do is take this and plug it into this equation and verify that it's true. So let's do that. So for k greater than or equal to 1, let's start by looking at the more complicated side, so the right-hand side. We have negative s sub k minus 1 over k. And so that's equal to negative. So now we're going to use the formula for s sub n. We're just going to replace all of the n's with k minus 1's. So it'll be negative 1 to the k minus 1 over, and then here we have k minus 1 factorial. So that's the top piece. And on the bottom, we just have our k. Okay, so we're dividing by k, so we're really multiplying by 1 over k. Because when you divide, you multiply by the reciprocal. This is really k over 1, and so the reciprocal is 1 over k. So this is negative 1 to the k minus 1 over k minus 1 factorial times 1 over k. Now what we're going to do is realize that there's a negative here. It's really a negative 1. So let's write this as negative 1 to the 1 times negative 1 to the k minus 1. And on the bottom, let's just take the k and put it in the front like this. K times k minus 1 factorial. And the reason we did that is that now on the bottom, k times k minus 1 factorial, that's k factorial. And then in the numerator, we add the exponents, so it'll give us negative 1 to the k, because 1 plus k minus 1 is k. And this is exactly the definition of s sub k. So we started with this piece here, and we showed it was equal to s sub k. That's exactly what we have in this recurrence relation. So we've shown that the sequence satisfies the recurrence relation.